This lesson is on adding and subtracting mixed numbers. So we've looked at how to get common denominators for just proper fractions. Now we're going to look at adding and subtracting with mixed numbers. So first I want to look at diagrams and how diagrams can be converted to mixed numbers. If we see in this first example here, we have a whole plus 1/4. So 1 out of 4 pieces are colored in. So I would say 1 and 1/4. Plus, this is again a whole, and here I have 2/4. So it's a good idea to count all the pieces inside the circle or the bars, the total number, and that will help you create the fraction of the whole. Let's go to the second example here. So here I have actually 2 full diagrams being filled in with color, and then 1, 2, 3, 4 total. That will determine the denominator, and 3 colored in, which will determine the numerator. Minus, we're not going to solve these for now. We'll look at solving them later, and then maybe we'll revisit these. I have a whole one colored in, and then again, 1, 2, 3, 4. So it's going to be out of 4, which is the denominator, and 1 on top. Okay, so you kind of see a pattern of how these work. Here again, count all the pieces inside. A 1, 2, 3, 4, 5. This time they're out of 6, but that's okay. Well, that'll change, or that'll help when we come to the fraction. So I have 2 full that are colored in, and then 1, 2, 3, and I already knew that they were out of 6, so 3 out of 6, plus 1 full, and then 2 out of 6 for that one. Back to circles again, but this time they're cut into different amount of shapes or different number of segments inside the circle. So I have 2 full circles colored in, and let's start with this one here. 1, 2, 3, 4, 5, 6, 7, 8 total. And I can see that 6 of them are colored in. Minus, here, I'll move that way over. So 2 and 6 out of 8 minus 1, 2, 3, I can see that's 4 out of 8. And 4 out of 8 is actually also equal to a half. Right? I can see that right away, that I could reduce that 4 out of 8 fraction to a half. Sometimes you don't want to reduce until the very end. You definitely want to simplify, but sometimes you wait until the very end, because if the denominators are the same right away, then that means I can subtract right away, because with adding and subtracting, recall that I need common denominators. So those are some examples converting diagrams to equations that we can now, I'll show you in these next examples, how you could solve them. Because in your homework or in your assignment, you might be asked to solve these as well. So then this will teach you how to go to the next step. So adding mixed numbers. Just going to go through adding first, then we'll look at subtracting, because subtracting involves a few more steps. So recall, with adding any kind of fraction, we need common denominators. So you need first common denominators. So in this first one, I have 6 and 2/4 plus 9 and 1/2. There's a couple things I could do. The first thing you're going to notice is that when I'm adding mixed numbers, it's really easy with these whole numbers out in front. You can just add them separate, or like add them kind of on their own. So 6 plus 9 is 15. Before I add those, though, I'm going to make sure that these have the same denominator. So 2/4, if you notice right away, I can actually reduce that, or I can change 1/2 to something over 4, which would be 2 over 4. So let's convert them to over 4. So I have 6 and 2 over 4 plus 9. And remember, I have to multiply the top by 2 and the bottom by the same amount. So I end up getting 2/4. Then I can add these, because 6 plus 9, like I said, is 15. And when I add fractions, remember, I just add the numerators and the denominators stay the same. So 2 plus 2 is 4 over 4. And 4 over 4 is another whole. So that will add to the 15 to become just 16 as a final answer. Moving on, 3.5 plus 9 and 6 over 10. Again, I could reduce this 6 over 10 instead of multiplying both the top and the bottom of this fraction by 5. But for the sake of this lesson, for this one, let's actually just reduce this fraction because we can. So I can reduce this by dividing both by 2. Divide by 2 and divide the bottom by 2. So I get 3.5. We didn't do anything to that fraction. Plus 9 and 3 over 10 divided by 2 is 5. Now, I'm going to stop there because this didn't actually make it easier. Because now a common denominator between 2 and 5 is 10. So I'm going to actually go back to my original question. I'm going to say the common denominator for 1/2 and 6 over 10 is 10. Both 2 and 10 go into 10. And so on the first fraction, I'm actually going to multiply that first fraction by 5. So I get 3 and 5 over 10 plus 9 and 6 over 10. Sometimes you have to do that. You say, well, you know what? Let's try to reduce the fraction, see if that will help. In this case, it didn't. So again, you can add the whole numbers together. 3 plus 9 is 12. And with the fractions, you just add the tops. So 5 plus 6 is 11 over 10. And 11 over 10 is an improper fraction, so I can reduce that. I say, how many times does 10 go into 11? Once. So 11 over 10 would become 1. And how much is left over? 1 out of 10. And this 1 here would add to the 12 to make it 13. So I'd actually end up with 13 and 1 over 10. Okay, you don't have to do that extra step. You could just look at 11 over 10 and say, you know what, that's an improper fraction. 10 goes into 11 once. That will add to the 12 to make 13. And then what am I left over after I take the 10 away from 11? I'm left with 1 out of 10. So 13 and 1/10. Okay, last example. 3 and 5. I know that a common denominator is 15, so I can multiply this one by 5. And I have to multiply this one by 3. So I get 4, and 5 times 1 is 5 over 15, plus 8. The whole numbers do not change. We're not changing those, we're just changing the fraction. So 3 times 2 is 6, over 3 times 5 is 15. 4 plus 8 is 12. 5 plus 6 is 11 out of 15. Can I reduce that? Nope. So that is my final answer. So adding mixed numbers, very similar to adding fractions, only you just have to add that number in front as well. And if you have like a value like this, like in part 2, where you have an improper fraction, it's going to bump that number, the whole number in front, up. Now comes the slightly more difficult part, which is subtracting mixed numbers. When we're subtracting mixed numbers, we have to first, step 1, change to an improper, actually both of them, change to improper fractions first. Okay, so the first step we do is we have to change these to improper fractions. So in this case, 9 and 9 over 10, probably try to reduce first before you do that. Maybe, actually probably won't even matter. In these examples, it won't matter most of the time. So 9 and 9 over 10, remember I take the whole number out in front, multiplied by the denominator, so it becomes 90, add to the top. So that becomes 99 over 10. Okay, so if I'm converting that to a mixed number, I take 9, multiply it by the bottom, 9 times 10, which is 90, and add it to the top. So 9 times 10, and then I plus 9. Same thing with this one. I'm going to go 2 times 5, and then add it to the top, which is 4. So I get 99 over 10 minus, because it's a subtraction question, 2 times 5 is 20. Or sorry, 2 times 5 is 10. 10 plus 4 is 14. So 14 over 5. Okay, so I just wrote that at the bottom just to kind of help you convert those mixed numbers to improper fractions. Now, same thing. I have to get a common denominator. I cannot add or subtract unless I have a common denominator. The first one's okay. I can see that both the 10 and the 5 go into 10. So I'm going to multiply the second fraction by 2. So I end up with 99 over 10 minus 14 times 2 is 28 over 10. And remember, you can use a calculator in this course. Don't be afraid. It's okay. So 99 minus 28. Remember, I just subtract the numerators. The denominators stay the same. I end up getting 71 over 10. And if I convert that back to a mixed number, 10 goes into 71 7 times with 1 left over. So my final answer is 7 1/10. Because we're subtracting and because we don't want to have to deal with borrowing values from it, sometimes it used to be taught that way. If you just convert it to an improper fraction first, you don't have to worry about any kind of borrowing, for this course at least, because we're not dealing with negative numbers. It makes it a little bit simpler. Improper fractions first. Okay, next example. 9 times 5 is 45. 45 plus 4 is 49 over 5, minus 3 times 4 is 12, and add it to the top becomes 13 over 4. So it's a little more complicated because if I look at 5 and 4, a common denominator between 5 and 4 is 20, because 5 goes into 20, 4 goes into 20. If I look at multiples of 4, 8, 5 doesn't go into 8, 4, 8, 12. Nope, 5 doesn't go into 12. 4, 8, 12, 16. You can see 5 doesn't go into that, so 20 is the only one that works. So we're going to be dealing with some large numbers here for a bit, which is okay, because remember, we have a calculator. So to get 20, I have to multiply this one by 4, and I multiply the top by 4. To get 20, I multiply the bottom by 5, and the top by 5. So I don't like doing large number multiplication in my head either. So 49 times 4 is 196 over 20, minus 13 times 5. You should know that one, but it's okay. 65 over 20. And I subtract the tops, 196 minus 65, which is 131 over 20. Let's convert that back to a mixed number. How many times does 20 go into 130? Well, if you're unsure, or 131, you can actually take 131, divide it by 20 to see the nearest whole number that goes into it. In this case, it's going to be 6. So 6 20s will go into 130, and what will I be left with left over? Well, we'll figure that out. But I know 6 times 20, or 6 times 2 is 12. So that's going to be 120. So 6 times 12 is 120. How much is left over from 120 to 131 is 11. Can I reduce that fraction? No. So that is my final answer. If you're unsure how I converted that, maybe just watch it again. Go back, do maybe a little review of how to, convert improper fractions to mixed numbers. Last example here before I get into a couple word problems. 8 4/5 minus 1 3/4. Again, we're going to convert these to improper fractions. So 8 times 5 is, of course, 40. So 40 plus 4 is 44 over 5 minus 1 times 4 is 4 plus 3, 7 over 4. And again, I have 20 as the common denominator, which is kind of annoying, but it's okay. And then times 5. So common denominator of 20, multiply the first fraction by 4, second fraction by 5. So 44 times 4, that's a big one. 176. But notice it doesn't take me that long. 7 times 5 is just 35 over 20. Right? Keep your calculator handy right next to you. It's okay. 141. So I subtract the top, so I get 141. The denominator, of course, stays the same. And again, we have to convert this mixed number back, or this improper fraction back to a mixed number. So I divide by the bottom, which is 20. See what the nearest whole number is, which is 7. And then if you're unsure too, you could always go, well, what is that? 7 times 20 is 140. And then I would have 1 left over on the top out of 20. Can I reduce that fraction? Nope. So that is my final answer. So subtracting mixed numbers, first of all, change them to improper fractions, then get a common denominator if you have to. If you don't have to, you don't worry about multiplying them by anything, right? Just get them into mixed numbers first still, or improper fractions first, and then do your subtraction. Okay, 2 examples I want to go through and then a final conclusion. So first word problem, a recipe called for 1 1/4 cups of chopped tomatoes and 4 2/3 cups of diced turnips. I'm not a huge fan of turnips. I do like tomatoes though. How many more cups of turnips did the recipe call for? Because clearly it called for more turnips than tomatoes. I would throw this recipe out because, again, I don't like turnips. But how many more cups of turnips did the recipe call for? So This is kind of your key. How many more means I'm going to have to subtract, right? How many more people are there than cats, or how many more cats are there than people? You subtract the two, whatever the larger one is, minus the smaller one, and then you'll get your answer. So large minus small, larger minus smaller number. Okay, so 4 2/3 minus 1 1/4. Subtracting. Oh no, I have to get them into improper fractions first. So what is the, well, first, yeah, get improper fractions. So 4 times 3 is 12, plus the 2 is 14 over 3. 1 times 4 is 4, plus the 1 is 5. So minus 5 over 4. Look at multiples in 3 and 4 to see what's common. So 3, 6, 9, 12, 4, 8, 12. 12 is common. So I'm going to have to multiply this one by 4 and this one by 3. So the first one, 14 times 4, maybe you can do that in your head. 56 over 3 times 4 is 12, we said. Minus 5 times 3 is 15 over 12. And then 56 minus 15 is 41 over 12. How many times 12 go into 41? Again, you can just divide by 12. 3 times 12 I know is 36. So I have 3 full 12s that go into 41, which is 36. And then I have 5 left over. 5 over 12 is already reduced, so that is it. So there are 3 and 5 12s. If you should actually write a statement, right? Because this is a word problem. There are 3 and 5 12s cups more turnips than tomatoes. Okay, so subtraction, fairly straightforward. How many more means subtract? You're going to take the larger number, subtract the smaller number. The larger number minus the smaller number, I guess. Last word problem. Melanie planted 2 1/4 rows of carrots and 1 2/5 rows. I know it's a long video, but this section is kind of complicated, right? So lots to cover. In total means add. This one's easy. In total, how many are there? The sum. So I take 2 1/4 of her rows of carrots, which I do like, and I add in 1 2/5 rows of onions, which I also like in many different dishes. And I'm going to add these together to see how many total rows of vegetables Melanie planted. So the numbers I can just add together. The fractions, remember I have to get common denominators. So the common denominator, 4 and 5 again, we know is 20. So I'm going to multiply this one by 5 and multiply this one by 4. So I get 2 and 5 over 20 plus 1, and 2 times 4 is 8 over 20. 2 plus 1 is 3. 8 plus 5, I never remember this one, but now I can remember it's 13. So at 13, I have a problem adding 8 and stuff and 7 and things, but that's okay. 13 over 20, can I reduce that? Nope. So I would say Melanie has 3 13/20 rows of vegetables. Okay, so in total, again, add how many more are there than you would subtract. And in conclusion, adding mixed numbers requires a common denominator, of course, like adding fractions. But you can add the numbers in front of the fraction first or at the same time, right? You can add them first or at the same time as when you get the common denominators. That's totally fine. Subtracting mixed numbers, however, requires a few extra steps. You have to convert to the improper fraction first, then subtract, then convert back to a mixed number. But in any case, always remember to simplify your final answer. Always check, can it be simplified? Can I make this fraction simpler? So again, this was a bit of a longer video, but a lot of concepts to cover here. So yeah, hopefully that helps.